Welcome to another GCBASIC demonstration for the PIC18FxQ24 series. This is part 19, Assembly, Alternative Assemblers and MPLAB-X. And the use case here, I'll explain in a moment. So, like and subscribe, let it run all the way through, give us some comments, make a subscription to GCBASIC. So, Assembly, Alternatives and MPLAB-X, why would you want to do this? You want to see how the assembly works, or you want to debug it line by line, or you want to program it using a different programmer that is supported by MPLAB-X. But as PICkit4, PICkit5 are both supported by GCBASIC natively, that would be a bit of a weak case. The main use case is debugging the code so you can learn how it all works. So as we touched on this, it's an open source compiler, supports Q24, and it's a common platform with common code translation. And that means that it will work inside of MPLAB-X. How does that happen? Well, typically what we do is we take your source program, we pre-process it with some libraries into a code translator, we assemble it for your target chip, and we write out an assembly file, an ASM file, ASM file. But we don't stop there. We go through, we then assemble that through a linker, and we produce a hex file. And that's through, oops, I'm so sorry. That's through GCASM. GCASM sits here. It's an internal part of the compiler. It's not exposed. GCASM sits here. We can see that in operation. Let's have a look at that now. So I'll shut down all the files that are open. Control B and open up 300. 300 summary examples. Very simple program. All it's got in it is the chip that we're using. I'll shuffle that across. Option explicit. Constant to define port B.0. Set that to out, and then it flashes it. What it does, it flashes it every 1 second. And to ensure it's using GCASM, if you open up the Preferences editor, in the Compiler tab, you can see there are different options here, GCASM. So when I press OK, it will change the setup to use GCASM. Now when I press function key F5, it will now compile it. It will then load it into the chip, and it will flash the LED. Well, here we go. LED is now flashing every 1 second. Perfect. So let's look at the source file here. It says here, I compiled a file, 300 summary examples, and it was assembled using GCASM, and that took 0.3787 seconds, and then it programmed it. If you want to generate a file that can go into MPLAB for debugging, because this chip cannot go into the old debuggers, it has to be MPLAB-X, you have to make a change, and you have to use PIC-AS. To get to PIC-AS, you already know how to do that. It's function key F4 into the Preferences editor. I'll zoom in on that. Compiler tab, PIC-AS, press OK. Now, what it's going to do, slightly different operation. Go back to PowerPoint to explain. Now what it's going to do is going to use this as my assembler and linker. So I can take the source code, come through here, assemble, and it's going to push out an assembly language file. Look, ASM's missing from here because it's going to push out something called .s, and .s is passed into here, and that will generate your hex file for you. Ugh, like that. I'll do that all again. Generate your source file into the code translator, into the assembler, and here it will create an assembly language file. In this case, a .s file. That .s file will be passed into PIC-AS, and it will generate a hex file. That's quite clever. See that in action. This is what we saw before. I've changed the setup. Remember, I changed it previously. Function key F5. No change to the program. All I did was change the tool, which is doing the assembly, and it says here quite clearly on the screen, assembling program for PIC-AS. 2.4 seconds. Bit slower, but sometimes it's faster or slower. Doesn't matter. And it's still flashing the LED. It's just created an additional file, a .s file. And how do we open that .s file? The classic function key F4 in here. Open S. Now, if you in here, you can open up the S file, and here it is. It's a complete file. I'll zoom out a little bit. There we go. So it's compiled for PIC-AS on a particular date. Slightly different layout from the ASM file, but that's the difference between ASM and PIC-AS. It's a different layout file. Essentially, the assembly is the same, but it's a good program that you can then pass into MPLAB-X. So why don't we do that? I'll minimize everything here. I'll come out of PowerPoint. And then inside of my windows, I'm going to start IDE, type IDE, and I've selected 6.2. Now this takes a few moments to load. Oh no, it didn't. It's loaded it because I already had it in the system. So what I'll do is I'll delete that. Project's deleted. I've loaded MPLAB-X. There we go. I've entered MPLAB-X. Okay, let's zoom in for you so that you can see what I'm doing. So create project, file, new project. And I will bring that window up so that you can see it. There we go. Yep. Microchip embedded, absolutely. Application projects, yes, that's the one you want. Next. Type in your chip name. Q24 is what I've typed. I'm select my 18F26Q24 and select the simulator. Because we're going to be using PIC-AS, I need to open up that little drop down there and select 2.5. And that selects the right tool. You might not have all those options. I've got lots of them because I've had all the old versions. And 2.32 is missing. I've already deleted that. It's so bad. Anyway, next. Type in the project name, Q24 demo. You can call it what you like. But what we're going to do is walk our .s file, if it works, of course. Next, once you've given it project name, project location, I put a /temp, and I had it set as main project. It creates a little skeleton project for you. Now, what we need to do is add into the source file our file. Quick way of doing that is go into GC code, right-hand mouse button on there, and just copy the path, and then back into MPLAB-X, source file, add an existing item. It will open up a dialog window, and just paste that file name in there and select auto. Mine's already selected. I'm going to try absolute actually. See if it fixes the problem I saw this morning. Okay, I've added it in just to confirm things. I go production F11, and if it compiles in the bottom window successfully, then we've basically done what we did in GCBASIC when we've generated a hex file, but we did it a lot quicker in GCBASIC. Let's have a look in the bottom window. It says it's loaded it completely. Loaded completed, that's correct. Let's walk the code before we program it. Debug, discrete debugger, build for debugging. And because we're using the simulator, we can walk the code in the simulator. If you have a PIC-Kit4, you can debug it in the chip. So what it's doing at the bottom, it's loaded a load of stuff. It's compiled it. It's loading complete. It's loading in the ELF files, which are files required for the debugger. And then up the top, debug, launch, debugger main project. Click. Exciting. What's it doing? Well, down the bottom it says loading. The screen has popped. It's opening up our source file. And where did it get that source file from? GCBASIC. So now in the debugger, I will not be teaching you debugging, but essentially push function key F7, and it is walking the program. It's walking the program successfully. This is exactly what it was doing, and you can walk the program. It's actually, this is all the assembly you don't see in the background, but you can learn it in here by walking it through. Now it's saying LED out, which is our constant. So it sets it, it's bit 0 lot. And then it says in here, toggle the LED, which is LED, not LED. It toggles all that lot. And then it does 1 second wait. You can learn simpler in here. And once it's done that, it will, let me just put a break in there for you. I'm not going to tell you how to do a break. You can go figure that out yourself. It will then go through the wait, and then it will come back to our clear. So it's walking the code. So how do I make it even smarter? I've got a PIC-3 attached. Let me just show you. LEDs flashing. Go into Zen mode. I'm going to open up PIC-2. I'm going to erase it just to set the scene. So 1, you can walk the code in MPLAB-X. I've shown you how to do that. Now we're going to program it from MPLAB-X because you might want to make changes, see how it all works. So in MPLAB-X, I am just going to make a little change. Right-hand mouse button on the word demo, and then go into properties. And this is documented in the PowerPoint, because in a moment, I'm going to go over to the PowerPoint to get the commands. First thing you need to do in the simulator, if you want it to actually do anything properly, you do need to make a little change, okay? And in here, in simulator, just change that to 64 or whatever frequency you programmed it at. Otherwise, when you run the simulator, it takes too long. Let me zoom in on that. I'll zoom out a little bit and press, oh dear, it's moving things around the screen. Look, press OK. Oh, you can apply that one. And then in the build, I want you to add in the command that was shown in PowerPoint. Now, I have shut PowerPoint down by mistake, but I will just open it up. And in our PowerPoint program, on the screen there, you can't see it, but I can. There's a command. Let me just show it to you. So there it is. It's in the PowerPoint. Just cut that from there and put it in here. And then you say execute this line after build. Okay. So now when you build, it's going to program it automatically. So let me try and put it in a position where you can see everything. Production, build. Now you've got to remember that if I go out to this mode, it's not flashing it. Well, why is it not flashing it? Because it just programmed it from MPLAB. If you don't believe me, I shall shuffle things around on the screen so you can see things. Oh, some error message coming up here I don't know what that message is, but it's clearly programmed because it says here, PICKITPlus, voltage, minimal, verify, setting it to 5 volts, took 4 seconds. So we clearly programmed this chip. So the main thing what you can do in here is you can walk the code. You can experience the program. And so we did that by going debug, build for debugging, and then I'll just bring that in so you can see it. Recap. Build for debugging main project, and then you can select the launch project. He's still doing it. I need to go back to, here we go. He's just thinking about it. And then you select launch debugger. So that's what I wanted to show you inside of MPLAB. Let me just go back to my PowerPoint. Let me get back to the slide where I was. So this is what we did. We selected the standalone project, we specified the chip, and then we selected PIC-AS. We gave it a name, and then we finished. Then later on, I used the debugger, I compiled for debugging, walked the debugger, etc. But then to program it, I changed the properties by setting the default frequency, not necessarily for programming, but for the simulation, you should do that. And if you want to program from MPLAB-X as you make your changes, add in this command line here. Oops, a daisy, but I went through it a little bit. Control Z. Let me just erase that pointer. There we go. It's that command line there. Press OK, and then if you want to test compile, press function key F11. So next, summary, pull it all together. I'll call it a day.